So we are given a plane here. So, and what we have to do is that there is a point with coordinates 1, negative 1, 3, and we have to find the coordinates of this point of intersection if this line is perpendicular to this plane. Okay, so if you look at the equation of the plane, or rather the given equation of the plane, which is x minus 2y plus 2z plus 9 equals 0, what this tells us is this, that the vector given by these coefficients here of x, y, and z, that will be 1, then negative 2, and then 2, that is perpendicular to the plane, and then consequently this vector will be parallel to this line. So first let's write an equation of this line. So an equation will be given by x equals, here is x coordinates, so 1, and there is the x component of the vector, so 1 times t, we are writing a parametric equation. Then y equals, take the y coordinate here, then minus 2 times t because of this second component negative 2, and then z will be, take the z coordinate, and then here the third component 3 plus 2t. So what we have to do to find the coordinates of the point of intersection is that we shall just go ahead and substitute x, y, z in this equation of the plane. Okay, so substitution of the x, y, and z coordinates from parametric equation of the line into this plane would give us this equation. And if we solve this equation, first let's just go ahead and open all these brackets. So when we expand all these and then combine like terms, we will get 9t plus 18 equals 0. That gives us t equals negative 2. So for the coordinates of the point Q, all that we have to do is that just substitute the value t. T equals negative 2. So x will be 1 minus 2, that is negative 1. Y will be how much? Negative 1 minus 2 times negative 2, that will be 3. And what z will be for q? 3 plus 2 times negative 2, that is negative 1. So this point Q has coordinates negative 1, 3, negative 1. Okay. Now we have to find the perpendicular distance of P from the plane, which will simply be the distance between P and Q. Okay. So let's do this here. We know that our P is how much? Our P has coordinates 1, negative 1, 3, and Q is negative 1, and then 3, and then negative 1 again. And we should just like notice this, that if we look at the vector PQ, then the vector PQ is negative 2, all right, 4, and then negative 4, and you can see that this equals negative 2 times 1, negative 2, 2. So these two vectors are parallel. And then the distance between P and Q will be the perpendicular distance. So you can simply use the distance formula between 2 points by Pythagorean theorem. It turns out to be how much? 6. Now, along these lines, you can derive a formula that you saw in the book for distance of a point from a plane. So here I just rewrote the question for you. So this is the point that we are looking at. So we want the distance between this point and this plane, and which is right here. So if you just apply this on these, what you will have is A is 1 here, and the x0 or the x coordinate of the point is 1, so we will have a 1, okay, then plus b, which is -2, then y0 is -1, so that will be +2, then cz0, that is c is 2, then 3 times 2 is 6, okay, and then we have our 9 here, and then we get a square root of 1 is square plus -2 is square plus 2 is square, so that is going to be how much? 18 divided by, this is how much? 1 plus 4 is 9, so 18 divided by 3. So the distance will be 6 as we calculated. So let's go ahead and make a plot in the MATLAB. So what we want to do is we want to graph this plane, and remember this, earlier we used the command fsurf to plot a plane. There we had to solve this equation for z. But if we want, we can just go by f implicit. And of course, we have to put 3 here. That is, we want it in the 3 dimensions. So that way we don't have to solve for z. Now we have to introduce the symbolic variables x, y, and z. And then introduce a function of x, y, and z as, g, x, y, and z by using this expression. So if we just, write this command, f implicit 3, and then g equals 0, you have to put 2 equal signs, and this is the graphing window. And we are just putting pbaspect as 1, 1, 1, just to keep the axis lengths as equal. So that will graph this plane for us. And then we are doing what? We are just graphing this vector here. So with this as the initial point and this as the terminal point. So the way we do that is that, remember this, we just do this, take the difference of the coordinates in order. So here we write for the plotting window in this manner, just write the pairs of the coordinates from this and this point, and line width we are keeping as 3. And now all we have to do is just do Control Enter, and the graph shows up. Okay, and you can just look at different views of this right here. So this is the plane, and this is the point of intersection, -1, 3, -1, and this is the starting point, 1. Oh, sorry, this is the point from where we were calculating the distance, 1, -1, 3. Okay.